Okay, let's start with the first module, which is all about the fundamental concepts of robotics. So here we are going to kick off the discussion with the essential definitions and introduction of whatever we need to know first about robots and robotics. Okay, so let's start with the definition of robotics itself. As said here, it is the industry related to the engineering, assembly, and operation of robots. At the same time, it is also something that deals with how any physical constructed system can perform a task or play a role in any interface or new technology. So we have to highlight some words here. First one, physical constructed. So physical constructed, it must have a physical body. Okay, it must be a physical object. All right, and that physical object or body must be able to perform a task or play a certain role. In other words, there must be some kind of motion for that task to be performed. Okay. Uh, if it only stands still and does nothing else, it doesn't move an inch, then that's not a robot. That's just a picture with a certain software, or that's just a statue that has some kind of software features. So that object must be able to move so that it can perform a certain task or play a role, just like what you see here in two of the most popular uh, robotic characters. We have Baymax and Wall-E, right? So now physical constructed. Aside from that, we have it must be able to perform a task or play a role. And lastly, there should be an interface or a new technology must be involved, right? And that's why robotics is considered part of the Industry 4.0 because it applies the different new or emerging technologies in the that come with the Industry 4.0, such as IoT, data analytics, of course, AI, so that it can perform some advanced tasks or play a more complicated role, a more complex role in any interface. Like it's not just in plain surfaces or in safe places. It must be able to go through rugged terrains. It must be able to go through rubbles or must dive into the ocean or underwater. Okay, so uh, we make use of new technology so that it can be um, usable, it can be movable, it can navigate through different environment. Okay, so now formally we have this definition: a robot is a computer-controlled device that has programmable multifunctional manipulator. So I underlined that word because take note, if a robot cannot be reprogrammed, then that's not really a robot. That's a basic toy or a basic machine. Okay, it must be reprogrammable and it must have a multifunctional manipulator. So most of the manipulators are something like a hand, but of course, robots come in different shapes and sizes. So there are many other ways to manipulate something, and you'll see that later. So it must be able to manipulate something. That's why we program and reprogram it, and the robot must be designed to move. The robot's manipulator must be something that is designed to move material, parts, tools, or specialized devices, or even itself. It must be able to move itself through variable programmed motions for the performance of various tasks. Okay, so as mentioned earlier, so in order for the robot to perform the assigned task to it, or to perform the task that it was programmed for, okay, it must have a body and it must have a way to navigate or to move and navigate if necessary. Okay. Now robots again come in different shapes and sizes, and it depends on the purpose of what they are, or It depends on what they are built for. But developers, engineers, roboticists have long been following the three laws of Asimov. Okay, in order for them to have a common ideology or common set of morality or something that they can consider as ethical aspect of robotics. So they somewhat follow or pattern their design in the Three Laws of Robotics, authored by Asimov, which is not an engineer, not a scientist or physicist. Yeah, Asimov is just is actually a fictional writer. Okay, he knows nothing about how robots work, but it was him who wrote a novel called I, Robot, and it became a play, wherein in this story, there's a part that he established these three laws. Okay, these three laws were featured for the first time there. Okay, so the first law says a robot may not injure or um, a robot may not injure a human being or through inaction allow a human being to come to harm. Okay, that's the first one. Best example for that is Hero of no Baymax of Big Hero 6. Okay, so if you have seen the movie, you see that Baymax does whatever it takes to make sure Hero is safe. Okay, so or at least in general context of robotics, um as long as it does not harm, it does not bring any harm to a human being. Okay, that it already follows the first law. Now, with the second law, once the robot has been able to follow the first law, then it proceeds with the second law, which says a robot must obey the orders given it by human beings, except where such orders would conflict the first law, right? So now that the robot has checked and verified that okay, this order given to me does not hurt a human being, then I will execute it. Okay, so the robot thinks of it first. Uh, the robot must decide or must be able to know whether that order will injure a human being or not. Okay, that order will whether that order will violate the first law or not. Okay, if not, then it will perform that order or that task assigned to him. Right? Now we have the third law, which says a robot must protect its own existence as long as such protection does not conflict with the first or second law. So, this is how the robot should think. It must check whether the certain task will injure the human being or not. If not, then it will check um, that how do I uh, how must I be able to perform this task? Okay. And thirdly, it will check if given the chance, how will I do this without sacrificing my own existence? Okay? How do I do this while at the same time protecting myself? Or in other words, how do I do this in the safest way possible? Right? So the robot will, for example, if the robot has to navigate from one point to another, and there are some obstacles and other forms of harm along the way, then the robot must perform the task, but at the same time avoid the necessary or the obstacles and other forms of harm along the way. Okay, it must find its way in the safest way possible. Okay, so with that, with these conditions, then we come up with the essence of our robot. Okay, and again, we have so many types of robots, and before we talk about that, let's have I think a quick tour at the history of robotics and AI. right? So just very brief. Okay, it's kind of blurry. Sorry for that. Brief. I'll just highlight some notable. Although everything's notable here, but I just highlight some of my personal um uh things here. The first things that I'll see here, right? Let's start with the although during the ancient times, there has been already a concept of robots or an artificial being that can perform some tasks. Okay, um, just like what we have in our definition. Okay, the idea was already there. Okay, but it was only in 1921 when the term robot was first used by Czech writer um, Karel Capek. Okay, so again, that's not he's not a physicist, an engineer, but rather a writer. Okay, so robotics actually came from fiction and before it became a reality, right? And then moving forward, we in 1941 we had the first the three laws of robotics, and that's why the concept of robotics has become more concrete. Okay, from being abstract, now it has started to become concrete, and engineers and physicists have started to see how possible this technology will come into reality someday. Okay, and one of the notable happenings during the 1950s is the development of the Turing's test. Okay, so this is where I think one of the events that led to the development of machine learning. Okay, so here this was the time, one of the times when uh, scientists and engineers were able to see the possibility that a machine can think for itself. Okay, or let's say the possibility of future artificial intelligence. Okay, so that was during the 1950s, and right now it's already a reality, and a lot has happened since then. Okay, we have to skip these parts, but I'd like to highlight the second one right here, during the 90s and up to the current years. Okay, so a lot has happened between these or before the 90s, but um in the 90s we had augmented reality. And then by what year is this? Okay, let's say around 2000s, we had the first self-driving car, 2000s to 2010s. It depends on the definition of self-driving cars. In 2012, we had the Google Now, the first version of Google Assistant. Like before, we have the Google Assistant, and I think what's the name for the current one? Um, the AI right now that we use for Google. Before we have that, we had Google Assistant, which is a descendant of Google Now. Okay, it's somewhat like the SimSimi of BlackBerry, I think. I'm sorry, I forgot. Um, and then what else? All right, so during the 2000s and 2010s, companies started to use the different technologies like, of course, the robotic arms. Even in 2010s, 2016 to be more exact, Amazon first used drones to deliver some goods in UK. Okay, and right now this application of robotics has grown ever since, and especially with the help of advancement in AI. Okay. Okay. So those are just some of the highlights, okay, on the history of robotics and AI. And in short, robotics have become more and more advanced because of the number one, because of the availability and development of newer materials. Okay, what we call smart materials. And secondly, because of the development of machine learning and AI algorithms. Okay, so we're going to talk about those things, of course, in the next modules one by one. But for now, let's proceed with the next in the next slide. Okay, we're going to continue this in the next slide.